Hi guys, we're moving on to Unit 4. This is 4A, notes on the new unit, function, relationships, page 70 in your purple book. We're switching gears a little bit, although really it all comes back and is related. Algebra has a number of different areas that we're going to study, and this one has to do with independent and dependent variables and ultimately functions. So you guys, I know in 7th grade last year, I'm pretty sure with Mr. Rock, you did quite a bit of work with independent and dependent variables. And they have a place in math too, and in graphing specifically. So in just talking about what a function is and what relationships are, one number to the next, we identify dependent and independent variables. Really, algebra is pretty much totally about the relationship between sets of numbers. So a variable that changes in response to another variable is the one that's dependent. He is the dependent variable. What happens to him is not under his control. It's under the control of the variable that is independent. So for instance, when we were doing the distance equals rate times time, the time was the independent variable. How long you're walking, you have control over. The distance depends on two variables, in this case, rate times time, but both the rate and the time are independent variables, and the dependent variable is d, the distance. So that's one example of that. So another way to say this, we can say distance is dependent on rate times time, but another way to say it is distance is a function of rate times time. Just like how much money you earn from your job is a function of how many hours you work that week. So we can use the word function, F-U-N-C-T-I-O-N, to describe the relationship that pairs each x value with exactly one output value. So in other words, if you work 8 hours one week and you make $10 an hour, there is exactly $1 amount that you're going to earn, 80 bucks. There's your independent variable, how much you work, and there is your dependent variable. So how much you earn, so we'll put hours, how much you earn is a function of how many hours you work. So functions express dependence of one measure on another one. The y value is the dependent variable, or the output. Those function machines that you used to do in 1st and 2nd grade, you put in a rule and out comes your output. That's what we're talking about here in a more sophisticated manner. The x value is the independent variable, and he's the input. You have control over the input. How long you walk, how many hours you work. That is independent. The output depends on the input. So another way of stating this relationship is what I just said. Y depends on x, which can also be stated y is a function of x. So both of these say the same thing, but the function term is really the more proper mathematical term that you're going to hear a lot in algebra and beyond, actually into calculus. So we're going to start using that terminology more than depends on. So let's look at some examples. There's one on this page and there's a few on the next page. I'll see how long this video goes. I may do this section in 2 videos. So it's asking you to look at these 3 containers over here and these 3 graphs. And we're trying to match which picture, which container goes with which graph. It tells you that, and if you'll read this carefully, each of these 3 containers holds exactly the same volume of water, exactly the same amount. Water is added to each at the same rate. Which graph shows the change in height for each container as you add the water? So if you kind of just look at it, I'm kind of seeing that A and C have sort of the same shape. They're both cylinders. One's a big long cylinder that's fairly wide, that has a wide circle diameter. The other one's not as wide, but he's still a cylinder. B is a totally different shape. He's a cone, upside down cone. So when you think about it, when you start adding water to each of these three individual shapes, what's going to happen? When you add the water, the height of C is not going to change very much because he's got so much space to cover. The height of A is going to go up a little bit faster than C because his diameter is smaller. But the height of B is probably going to go up the fastest to begin with. And then as the distance from this point to this point in B gets further apart, he's not going to rise as high. So let's see if we can look at these three graphs and decide which one goes with this one. You notice that these two graphs are both straight lines. That might tell me that they go with A and C, just because A and C are the same type of shape. But let's see if we can kind of prove it. If you think about what's happening in graph number 1, the volume goes up, the height goes up really quickly. You can see that right here, real quick. And then it goes up some more, but it begins to level off, level off, level off, level off. The next one, the volume. As the volume increases and you're filling the water, the height's not rising hardly at all. Not really very much at all. Even toward the end, the height is moving slowly. And in the third graph, you start out with the height moving higher than example number 2, higher, higher, higher still, and pretty much advancing in the straight line. So I'm not sure what you're thinking, which graph goes with which, but I'm sort of seeing that number 2 goes with number C. His height doesn't rise up. We said it doesn't go up hardly at all until the volume of the water really gets in there. So they have to be running that water in there at a pretty good rate before it makes a difference on how high he goes. This graph right here starts, and it goes up more substantially than this one does, but still it's pretty steady as you go. And that makes sense because this cylinder, he doesn't ever change his diameter, nor does this guy. His diameter stays the same. So if your water level, if you don't turn your hose on faster or slower, it's going to rise at the same rate. So I think this one goes with A, and that leaves us to look at this one. Does this make sense for the cone? Yeah, it does, because it goes up really pretty quick, and then levels off, levels off, levels off. So this one goes with B. So it asks us, okay, we already did that. Which graphs show the height? And I want to talk about what the relationship is, how we could state that in English words, what we're seeing in these graphs, and what I kind of colored in the drawings. We could say height of container depends, or the height of the water in container, I guess, water in container, depends on the volume of the water. And if we want to replace the word depends on with our new function term, we could say the height is a function of the volume. So notice again that the independent variable is on the x-axis, which is almost always the case. This is the x-axis, the horizontal axis. The dependent variable is on your y-axis, and I feel sure this is the way you were taught in science last year, and this will almost always be the case. All right, I think I'll stop this one and we'll do the other two examples in the next video. Thanks for watching.